we're looking at still absolute value, but this time we're going to look at equations. So remember that in an absolute value, the absolute value of a number, let's say it's 4, that means that this could be 4 or it could be -4. So really, when I'm solving an absolute value equation, there are two cases. The positive version, right, the version that I was given, and the negative version of that. And so I need to solve both. And I also need to check both. So we'll look at different ways you can check by hand, like we did with radicals, or by graphing. Okay, so what we want to do, our steps for solving these, we want to isolate the absolute value expression, which I'm just going to abbreviate like that. Then I want to set up my two cases and solve each. And then I want to check for extraneous solutions. And when I check for extraneous solutions, this happens in the original. So now I'm using all caps, but I want to be really clear about that. So we're starting off with a rather simplistic example and then kind of working our way up to more complex ones. So here the absolute value is already isolated. So now I'm going to do my two cases. X is 8 or X is -8. And when I do the two cases, I'm just going to type this in, remove the absolute value symbol, right? I get rid of that. All right. So X is 8, X is -8. I could check it, and you can see obviously that those are both good answers. Okay, so the check here, I'm just going to be lazy and skip. This one, again, it's isolated already, our absolute value. So either X minus 4 is 9, or it's -9. And now I'm going to solve both of these. So add 4, X is 13, add 4, X is -5. So I have two answers that I need to check, and I'm going to put them back into the equation. So 13 minus 4 in absolute value is 9, and -5 minus 4 is 9. 13 minus 4 is 9. The absolute value of 9 is 9. Yep, that is a good answer. And over here, -5 take away 4 is -9, which is also 9. That's also a good answer. So I have two solutions in this case. X is 13 or X is -5. All right, over here, I'm going to clear that up so I have some more space. I'm going to start by isolating 2x minus 5 in absolute value is -3x plus 5. And now I have my two cases. So either 2x minus 5 is -3x plus 5, what I have up here, or 2x minus 5 is positive 3x minus 5. So here I might start by adding 3x on each side. 5x minus 5 is 5. Add the 5 over, this one I mean, it's 10, and x is 2. So there's one of my answers, which I'm going to check. And over here, I might move this 2x over by subtraction. So I'm just going to get 1x minus 5. And x is 0 is my other answer. So I'm just going to do my check up here where I have some more space. So if x is 2, I'd have 2 times 2 minus 5. Minus 5 is -3 times x, which is 2. So over here I get -6. This is going to be 4 minus 5 minus 5. So -1. The absolute value of -1 minus 5. And 1 minus 5 is, -4, which is not -6. So this is extraneous. Do you remember that word from before? So this is not an answer. And now I'm going to do the same check, but if x is 0. So I'd have 2 times 0 minus 5 equals negative 3 times 0. This side is 0. 2 times 0, well, that's just 0 minus 5. So the absolute value of minus 5, take away 5, is 0. So here this one works. So this is my only solution. The other one turned out to be extraneous. Okay, so now I've got 2 more linear ones for you to try. Give them a go. Maybe pause the video here, try and solve them, and then I'll show you the answers. Okay, so this one, the radical, I keep saying the radical, the absolute value is isolated. So x plus 5 is 11, or x plus 5 is negative 11. On this side, x is 6, and on this side, x is negative 16. And now I'm going to check, and I'm going to check. Whoops. 6 plus 5, 11. 11 in absolute value is 11. Yep, so this is a good answer. And negative 16 plus 5 is 11. Yep, this is also a good answer. So in this one, I have 2 solutions. Over here, I have to first move my 1 over. And then I have my 2 cases. X plus 5 is 4x minus 1, or x plus 5 is negative 4x plus 1, the negative version. So here I'm going to say 3x minus 1 is 5 by subtracting that x, and then add 1, x is 2. And then I might as well check that while I'm at it. 2 plus 5, and I'm checking in the original, which is up here. Plus 1 equals 4 times 2. So this side's 8. This is going to be 7. Plus 1 is also 8. So yep, we are good. This is a good answer. And now I'm looking over here. And I subtract 1. So negative 4/5, or maybe you got negative 0.8, means the same thing. And we'll check this one. So over here, I'm going to get, what is this, 16 over 5, which is 21 over 5. And on this side, negative 16 over 5. Oh, these do not equal. So this answer up here is extraneous. So you can see the importance of checking your answer, right? You always want to check. Don't forget, that's really important. So those are kind of the linear ones, all right? So we saw 4 examples of linears. And now I just have 2 down here for quadratics. So remember, quadratic means I'm going to have an x squared in it somewhere. But the process is the same. So down here, either x squared minus 2x is 1, or x squared minus 2x is negative 1. And now I have to think about how to solve a degree 2 or quadratic equation. Well, I can factor. I can use the quadratic formula. I've got options. So if I'm going to factor, I want it to be in the form x squared plus bx plus c equals 0. And actually, I want it in that form for the quadratic formula as well. So let's do that. And this one can be factored. So I have an answer there, which I'm going to check. So I would go 1 squared minus 2 times 1 equals 1. 1 squared is 1. This is 2. That's negative 1 equals 1. Yep, that is a good answer. This one checks out. So here's my check down here. This one, I'm unfortunately not going to be able to factor, so I have to use the quadratic formula, which I know is a bit of a drag, but I get 2 plus or minus the root of 4, this squared, minus 4ac all over 2a. And this turns out to be 8, so this is really 2 plus or minus 2 root 2 over 2, which is 1 plus or minus root 2. So these two answers here, remember this is x equals 1 plus root 2 and 1 minus root 2, are a little bit harder to check by putting them into here. So one trick I have is graphing to verify. So what I'm going to do is graph this as my y1. So remember x squared minus 2x. If I graph, just a little sketch of that is going to look something like that. And the line 1 is going to look something like that. And I can see my solutions. This is x equals 1. This one is 1 minus root 2. And this one over here is 1 plus root 2. So these answers are all good. This one, and this one up here. Okay, so sometimes graphing helps, and I want to graph the original. And remember, if you're looking for how to put in the absolute value in the TI calculator, you're going to hit y equals, and then you're going to hit the math button. And if I hit math, I hit over to the right once to number, or num it says, and then my first option is abs. So that stands for absolute value, and that's where you can graph those, and then you can do your intersections and so on. Okay, let's look at this last one. So I'm going to clear up some room here so I have some room to work. Okay, this guy. So I'm going to isolate like that. And now either x minus 10 is x squared minus 10x, or x minus 10 is negative x squared plus 10x. And now I have two quadratic equations. So this one, I'm probably going to move these two factors over here and get 0 is x squared minus 11x plus 10. And I'm going to factor that, x minus 10, x minus 1. So I get the answers 10 and 1. And then over here, I'm probably going to add these two to this side because I prefer a positive x squared. So I'm going to get x squared minus 9x minus 10 is 0. So I hope you got that. And then x minus 10, x plus 1 are my factors. So this one factored, both of them factored nicely. 10, I get a repeat of that, and I get negative 1. So now I have to check 1, 2, 3 solutions to see are any of them extraneous. So try that and see what happens. And you should get that this one turns out to, or sorry, the positive one turns out to be extraneous. Sorry, yeah, it's the positive one. This one's extraneous. So you could try graphing it as well. So if you graph, this side is y1, and then just regular x squared is y2. So let's look at that down here. So I'm going to graph x squared so on, whatever, something like this, right? It looks something like that. And that is y2 is x squared. y1 is the absolute value of x minus 10, close the absolute value, and then outside plus 10x. So if you take a minute and put that into your graphing calculator, the combination here of an absolute value and then plus 10x kind of looks like a bit of a straight line. And you can see that our second line comes up through here, and then that other intersection, you can see that x squared and this line are getting closer together, but you can't quite see that intersection point, so you have to change the window. And what do I want to see? Well, I want to see farther up here. So I'm going to make my y max, I don't know, 150 or 200 or something like that, and then look for your intersections. And you're going to see that one of them's right here at x equals -1. So that was, if I zoom out a little bit here, that was this answer. And then for 10, for x equaling 10, I've got to go all the way up here to where my parabola and my other function meet. And so you can see that answers are x equals -1 or x equals 10.